The OSI model, Section 1, Group 3. Layer 7, the application layer. This layer provides interfaces for applications to access network services, which include file sharing, message handling, database access, and error recovery. The protocol data unit, also known as the PDU, is in the data format. Both have client and server components. Examples of the application layer include the web browser, which is the client component, web server, the server component. Both use the HTTP protocol. Other common protocols include FTP, SMB, CIFS, TFTP, and SMTP. The sixth layer, the presentation layer. This layer handles protocol conversions, data encryption and decryption, data compression and decompression, data representation incompatibilities between operating systems, and graphical commands. Outgoing messages are converted data into format specified by the application layer, and incoming messages reverse the conversion if required by the receiving application. This layer presents data into suitable formats for the application layer, and the PDU in this layer is in the data state. Examples of the presentation layer include the web browser connected to secure web servers. The encryption protocols must encrypt data before it is sent to the server, and decrypt data that arrives from the web server. Software components, the redirector, intercepts and redirects requests for service to a network resource that can handle the request. Components of the layer include FTP clients and servers, HTTP clients and servers, and operating system specific clients and servers, which include client for Microsoft Networks, file, and printer sharing.
The fifth layer permits two computers to hold communications across the network. It allows either application to exchange data for as long as the session lasts. It handles communications between setup, ahead of data transfers, session teardown when the session ends, and common uses of it are name lookup and user logon and log off. The layer also manages the mechanics of ongoing conversations, identifying which side can transmit. Checkpointing synchronization processes between two related streams of data. An example of this is audio and video streams in a web conference. It keeps the audio in sync with the video. Authentication protocols such as DNS, FTP, client for Microsoft Networks, NFS, and PDU data. The fourth layer manages data transfers from one application to another across the network. It breaks down long data streams into segments. Segmenting data is important. The segments must be smaller than the network's maximum transmission unit. This includes flow control and acknowledgments. It ensures that the recipient does not receive more data than it can handle, because this could result in dropped packets. It handles resequencing segments into the original data on receipt. The source and destination port numbers. Each application or service is assigned to a unique port number. When data arrives, the transport layer protocol knows where to send the data. Sequence and acknowledgement numbers, only in TCP headers, used to ensure that all data is sent and received. If data arrives out of order, the sequence number is used to reorder the data. Window size specifies the maximum amount of data that can be transferred before the sender requires acknowledgement. This provides flow control, not allowing a computer to be overwhelmed with data.
Network layer, layer 3. It handles logical addressing, translates logical IP addresses into physical or MAC addresses, and packet routing. PDU packets, protocols, and software. IP Internet Protocol, ICMP Internet Control Message Protocol, ARP Address Resolution Protocol, and the devices are the routers, firewalls, layer 3 switches. Data link layer, layer 2. It defines how computers access the network medium. The MAC, or Media Access Control, address is also defined. It provides physical device addressing, device-to-device delivery of frames, and media access control. Data link layer. PDU frame, protocols and software, the Ethernet token ring, FDDI, the fiber distributed data interface, NIC driver, and devices are switches and NICs.
The final layer, the physical layer, converts bits to signals for outgoing messages and converts signals to bits for incoming messages. It also encodes bits with ones and zeros. Types of signals generated depend upon the medium, which could either be wired media, fiber optic, wireless media, or twisted pair cabling. The physical layer also uses bits as the protocol data unit, and as for devices, it uses network media hubs or repeaters and connectors. Here's an animation of how the OSI model works. As you can see, it sends data through the application layer the whole way down to physical, and then it works its way back as it's receiving the data.